This is going to be Arduino 210, okay? Each of the 200 series is going to focus on some sort of input and the light's reaction to that input. The 210 series, 210, 211, 212, etc., will be focused on buttons. This is an intro to buttons here, and so we're going to be looking at just reading a button, different ways to read the button, and ways to interact with the LEDs. And we're going to be making some games also, some games and some actual like tools with this later in this series. But let's hook up the actual button here and hook up the NeoPixels to a pin. So I'm going to unplug my Arduino here. Okay. I'm going to put power into 5 volts. There it is. Ground into ground. And I'm going to use A0 for my data. A0 is also pin 14. And that way I can keep it sort of neat looking for the videos here. Keep the magic of Hollywood alive on YouTube. Okay. And then the button, there's another ground on this side right there. And then don't use pin 13 on these things. Pin 13 can mess you up. That's because there's an LED attached to it. Okay, so I'm going to go to pin 12. Okay. So let's flip it. There we go. So I can access the button. And then let's make sure we can see the LEDs here. With a little twist. There we go. Cool. Okay. And so, first thing we're going to do here is just turn on the LED when we turn on the button. Okay. So, here's the basics of the code. I think I went over this in the 102 or 103, how to extract this from the code here. Okay. So, we need our library, right? We need the LED pin, the LED count, and the object creation. Our object is called strip here. Okay. And then under setup, we need to do a strip.begin, and we don't need to do a strip.show. I just like to do it because it keeps everything clean. Okay. So our LED pin is 14 or A0, but I don't think A0 comes up as 14. And LED count is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Got 11 LEDs. Cool. Okay. So if we were to upload this right now, it wouldn't change much, right? Like it would just show everything off, which it already is. So not gonna upload this yet. And let's take a look at buttons. So I plugged the button here into pin 12. And then there's ground right here. So what it's gonna do is connect ground to pin 12, right? It's gonna ground out that pin. So we're gonna keep that in mind. What happens if I were to push this button? It's grounded out, right? Now that pin equals low or 0 or false, whatever you want to call it. I let go. You'd think that pin would just magically come up by itself, like back up to 5 volts, but it doesn't. And so what it'll do, like even as I put my hand like near it, it'll fluctuate voltages and give me a positive and well, I guess it'll give a reading of 5 volts or reading of 0 volts, right? As I bring my hand closer and further from it. So it'll be like randomly triggered, like as voltage just in the air, or if I touch it, it'll change the voltage. So what we can do in our code is pull that pin high, like but very weakly. So I'm going to type in under setup here, pin capital M ode, start my parentheses, 12 comma, all caps input underscore pull up, in parentheses semicolon. I guess I should put that an N in there. All right. So we have pin 12 now pulled up very weakly. And so when I'm not pushing this button here, that pin's going to read high or 5 volts, right? There's going to be a very weak resistor inside the chip here pulling this pin high. When I push it in, it's going to be pulled low. Okay? So keep that in mind. Let go is high, push in is low. Okay? Now you'd think there would be like an input pull down, This board does not have a pull down. Some boards do, like the ESP32s. ESP32s have a pull down, and so you push the button and connect it to 3.3 volts, and that pulls it high, and then you let go, and it's back to 0. It's a little more human that way, but Arduino Uno does not have that capability. Okay, so let's go to our loop here. Let's start actually coding something. Okay, so we're going to do an if statement here. If, so I'm going to show you 3 different ways that mean the exact same thing, okay? If digital read, I guess I'll show you a ton of different ways that show you the exact same thing. 12 equals. So if we push this button in, it's pulled down low, right? Because it's connecting ground to that pin, right? The black goes into ground. And then if I push the button in, it makes contact going out the blue into pin 12. So if I push that button in, it's going to be low. If I let go, it's going to equal high, right? But I want to read that button press. I want to read that low press. So if digital read 12 equals, we always do 2 of them to test. A single equal assigns, a double equals test to see if it equals. Okay? So equals low. Let's do something. Okay? Okay. Now let's look at another way to write this. If digital read 12 equals 0. That's the exact same thing, okay? Low and 0 are the exact same thing. When the compiler comes through, it actually takes all these blue parts out of here and replaces them with a number or something else, okay? So low also means the same thing as false. Also means 0, okay? Don't know if I typed in false right, but whatever. Okay, so there's another way to write this, okay? So if, and this one won't make as much sense until the one afterwards. Read 12 does not equal high, right? Then do something. So equals lower does not equal high, right? So if it doesn't equal high, then it equals low, and that'll be true and run everything inside the curly brackets. So these are still all the same thing, right? Now I could also write, instead of high, 1. Okay? Let's look at the next one. So if digital read, oh, whoops, 12. There we go. Okay. So these if statements, let's take a look at that. If true, do something, right? Maybe it's lowercase on this. Yeah, there it is. Okay, yeah. So if true, do something, right? So right now, no matter what, every time it passed through this thing, it would run this code. Okay. So what this if statement is looking for is it to return a 1 or a 0 inside here. Okay. Well, coincidentally, the digital read, the button read, returns a 1 or a 0 every time, right? So if I'm pushing the button, it returns a 0. If I let go, it returns a 1. So how can we use that, right? Because it's opposite. So what we can do here is if not digital read 12. So when I'm pushing it, it returns a 0, right? And then not inverses it to make it a 1. So now, if you're pushing the button, let's do something. Okay? So why am I talking about this? Because this is how we're going to be writing in the rest of the 210 series. Anytime we're reading a button, it's going to look at this here, okay? So get rid of all these archaic ways of reading pins and do it the cool way, Okay. So now if we're pushing the button, let's let's turn on that pixel. Let's turn on, I guess, the fourth pixel. So pixel 3. So strip dot set pixel color, and we'll make it blue. So 0 red, 0 green, and 100 blue. All right. And strip dot show. Cool. Okay. So let's upload this. Oh, I guess I better plug it in before it compiles. The race is on. All right. Takes me a while to compile, anyways. I've got one of them hard disk drives that doesn't like to read very fast. Oh, it's done uploading. Cool. Okay. So as I push this, it turns it on, right? As I let it go, it never does anything else, right? So I'm going to run the reset button on my Arduino. Okay, back to off. Push the button, and it's on. And it stays on. Okay, that is because I never told it to turn off, right? So if you read the button, if the button's being pressed, turn the pixel on and broadcast it, right? Okay, so now we need to write. I'm going to just copy this and paste it. So if the button's let go, I'm going to get rid of that not. So if the button's not being pressed, set that pixel to just 0, right? 0 red, 0 green, 0 blue, and then show it. Let's give that a try. Okay. All right. So now it's off again, right? We've been here before. Push it, it's on, let go, and now it's off because it actually has a condition to show whether it's on or off, right? Okay. So let's clean this up. Let's clean this code up a little bit. So first of all, if the button's being pressed, it shows the pixel, right? If the button's not being pressed, it shows the pixel. So no matter what, it shows the pixel. There's no point in having this inside the if statement here. All right. So upload that, make sure it works. So all it's doing is inside memory turning that blue on or turning that blue off. And then it's going to show it depending on whether button's pressed or not, right? It'll change the color. So a very familiar program, just a little bit cleaner, right? One less line we're doing anyways. It makes a little more sense. Okay. So we talked earlier about how digital read returns a 1 or a 0, right? So let's look at that. This isn't going to be the most practical setup, but this is just to show you like how you can manipulate numbers inside Arduino here. So instead of 100, we'll do digital read 12 times 100, right? So digital read will either return a 1 or a 0. 1 times 100 is 100. 0 times 100 is 0. Okay? But it's going to be opposite. And so how do we fix that, right? So now it's on. I push the button, it's off, on, off. And so it's opposite of what I want, right? When I hit the button, it should turn on. Well, that's easy to do. I can put a not right there. Okay? Now let's give this a try. Now it's off. I push a button, it's on. Okay. So I hope that helps you understand how digital read works. Okay. Now what I want to do, instead of just having it while I'm pushing it, I want to push it. It's on. I push it again. It's off. Okay. So there's a couple things we have to track here, and I'm going to do it wrong a couple times just to show you why it's wrong. Okay. So first of all, we need to keep track of the actual LED state. So make a bool called LED. Okay. Get rid of this. So if digital read 12, not digital read 12. Okay, so if I push the button, LED equals not LED. So if the LED was a 0, it would now equal 1, right? And if it was a 1, it would now equal 0. Okay? So it's basically going to flip the states. And then we need to do a strip dot set pixel color, and we'll make it green this time. So same pixel, I guess 4 comma 0 comma LED times 100 comma 0. All right. And then of course the strip dot show, and this program will not work very well. And we'll explain why. So when I push the button, LED's right now at a 0. If I push the button, it'll turn it to a 1. It'll take that 1 and multiply it for 100 for the green, and it'll show this, right? Makes sort of sense. But I'll show it to you. And we're going to look at the issue here. So I'm going to push it. All right. So sometimes it works, sometimes it doesn't. Right. Okay. That's because it reads it, switches state, sets that state into memory, broadcasts that memory, comes to the end of the loop, comes right here, reads it again. And so this is like within nanoseconds that this is happening. So by the time I let go, it's already switched the state like 100 different times, right? So we need to have something to like latch on to when I let go of that button. Okay. So one more boolean here called latch. So if I press this button, latch equals 1. All right. But if I press the button, I need latch to be 0 for me to actually press the button. Okay. So if not digital read 12 and not latch, right? So the button's got to equal 0. The latch has to equal 0. If both these are true, right, because we're switching them, so this will be a 1, and this has to be a 1. If both these are true, then we'll run this little program here, which will disable this from actually running again. Okay? So now we do if latch and digital read 12. So now, if you let go of the button and latch is set, latch equals 0. And now you're able to push it again. Okay, so this is going to work better, but it still won't work right. And we're going to talk about something called debounce. And you would think electricity would just go from 0 volts to 5 volts, like real easy, no problem, but it doesn't quite do that. Okay, then we hit it, and it's on. Oh, it's on again. It's off, on, off, on, off, on, off, on, off. Oh, that one went on again. So it sort of works, but it has these bugs here. Okay, that's because once I push it, the voltage comes up a little bit, right? So the voltage, well, I push it, the voltage comes low, kind of. There's a slight bit of electrical bounce in there that makes the voltage, so voltage comes high, right? And then I push the button, it's low. It doesn't quite go straight to low. It goes eventually to low, like within like nanoseconds, picoseconds, it goes low. But then it sort of wanders back up a little bit and then comes low again. It's called electrical bounce. And so that wandering back up in the code here can delatch that button and then it runs it through again. So over time, like it can sway a little bit. So what we're gonna do here to fix that is do a tiny little bit of a delay. We'll do a delay of 10 milliseconds. And that's overkill, but it works. As humans, we're not going to have an issue there. Because unless we can touch this thing faster than 20 milliseconds, it's not going to be an issue. What is that? 50 times a second? Yeah, that's pretty fast. That's like subwoofer frequency. That's faster than the bass note on a bass guitar by oscillates. Okay, so upload that and let's see if we're steady now. So when I push it, it's on. Push it, it's off. Tested a bunch. And now we're perfectly steady. Cool. All right. So this is the intro to Button. We're gonna make a ton of things based off this in the next few videos. So get ready to have some actual like fun with this stuff. Thanks for watching.